Assalamu alaikum students, unit number 2, real and complex number, and exercise number 2.5 we will start. Before starting exercise number 2.5, we need to know about the complex numbers. As you have already studied in the very early of this chapter, natural number, whole number, rational number, irrational number, in set of integers, and now a new type of set, a new kind of set, which is the complex number, set of complex numbers. Let's study this. We recall that the square root of a real number is non-negative. The square of a real number is non-negative. You find square root, always you find the square root of a number, square root 5, square root 4, it will always be a positive. It can never be negative. Every time you find square root of numbers, you will find a positive result at the end. So the solution of the equation x square plus 1 equal to 0 or x square equal to minus 1 does not exist in R. He's saying that we know to find the square root of real numbers. Square root 7, square root 8, they are all positive. Don't know what is their answer, but square root always give a positive value. But if you solve this type of equation, x square plus 1 equal to 0, x square is equal to minus 1, to overcome this inadequacy of real numbers, we need a number whose square is minus 1. Thus, the mathematicians were tempted to introduce a large set of numbers called the set of complex number, which contain R and every number whose square is negative. They invented a new number, square root of minus 1, called the imaginary unit, and denoted it by the letter iota, having the property that iota square is equal to minus 1. Obviously, iota is not a real number. It is a new mathematical entity that enables us to enlarge the number system to contain solution of every algebraic equation of the form x square minus a, where a is positive. By taking new number iota is equal to square root of minus 1, the solution x square plus 1 equal to 0. It will be square root of minus 1, square root of minus 1, that is iota comma minus iota. I have read this paragraph, and let me explain you what he is saying. He said that the square root of a number is always non-negative. But what happens if we have a given equation x square plus 1 equal to 0? It is equal x square equal to minus 1, and then we find the square root x square is equal to plus minus square root of minus 1. So square root of minus 1 not exist, and because square root is always a positive value, he said that and invented a new number. That is, he said that square root of, whenever you see square root of minus 1, say it as iota, and it is a complex number. And here, as we find two solution, x equal to plus minus square root of minus 1. Here the solution set is iota comma minus iota. Iota is a complex number. It has value iota is equal square root of minus 1, and also if we take its square, iota square is equal to minus 1. So whenever you are going to find the square root of a negative number, say minus 36, you write it as 36 multiplied by minus 1. The square root of the 36 is 6, and it is square root of minus 1, and you write it as 6 iota because this is a complex number. A complex number is square root of minus 1, which is represented by iota. And let's read again now about further information. Note, the Swiss mathematician Leonhard Euler 1777 to 1783 was the first to use the symbol iota for the number square root of -1. Numbers like square root -1, square root -5 are called pure imaginary number. Integral power of iota. By using iota is equal to square root of -1, we can easily calculate the integral part of iota. Iota square, iota cube, iota 4, iota 8 and iota power 10. We can use the integral part of iota. This is an important thing I am going to describe you, because we'll use this result in the exercise 2.5. He said, now you will study about iota square, iota 4, iota 25 and iota power 8 and so on, many more. Integral power of iota. As you know, iota square is -1. Iota 4 can be written as iota 2 power 2. Iota square equal -1 power 2. -1 square is +1. Similarly, we will approach this 25 by writing iota power 12 whole power 12. 2 12s are 24, but we want to make power 25, so multiplying with an iota again. Now iota square is -1 power 12 into iota. -1 power 12 equal 1 into iota is equal to iota. And iota power 8 can be written as iota 2 power 4 -1 power 4. -1 power 4 is equal to +1. This is the way you calculate the integral part of power of iota. Now the definition of a complex number is a number of the form z is equal to a plus b iota, where a and b are real number and iota is equal to square root of -1 is called a complex number and is represented by z, that is z is equal to a plus iota b. Students, mark this definition of complex number. A number of the form z is equal to b plus iota, a plus b iota, where a and b are real number and iota is equal to square root -1 is called a complex number and is represented by z, that is z is equal to a plus iota b. Z is equal a plus b iota. Now it has different examples. 3 plus 4 iota, 7 plus 8 iota, where a is equal to 3, b is equal to 4 and in this case a is equal to 7, b is equal to 8. Set of complex number. The set of complex number is denoted by C and is written as C is equal Z, such that Z is equal to a plus b iota, where a and b belongs to real number and iota is equal to square root of -1. The numbers a and b are called the real. The number a and b are the real and imaginary part of the Z are denoted by a is the real part and b is imaginary part. We will use to separate out real and imaginary part in the exercise that will I explain you in the next lesson. Thank you so much, students. I hope you understand this. Inshallah, in the next lesson we will see the exercise question and use these results, this definition in the exercise. The exercise is an easy one. Inshallah, we'll start in the next lesson. Thank you so much.